In this second example for expected values, we're going to look at a very specific case, and that is the case of life insurance. If you're not familiar with life insurance, it is a wonderful thing that has helped many people, myself included, and as they go through some trials in life. So, the basic idea of life insurance is you pay the life insurance company a little bit every year. Uh, well, it seems like a lot, $400 or something like that. 500, 700, depends on a lot of things. Anyway, you pay a certain premium to the life insurance company, and then should someone pass away in your family, then the life insurance company will pay you back a certain amount of money, and greatly helps out through lots of troubles. So, uh, anyway, let's go through this example and see how it could benefit us in general. So, in this example, we have a 30-year-old man who purchases a term life insurance policy of $150,000 for an annual premium of $250. The probability that the man will live through the entire year at an age of 30 years is 99.8%. So, 99.8% chance that he lives. Thus, what's the probability that he dies? Take a second, calculate that. That would be the complement. That means that there is a 0.2% chance that this man dies through the year. Not a very high chance, but still, let's continue. All right, so in this case, we have two different possibilities. Either he lives or he dies. Now, when we've calculated expected values so far, we've always had a number attached to the category. Well, we don't have a number attached to the category this time. Sometimes you can create a category that makes sense, so, or a numerical pattern. So, for example, a separate example off to the side, pain level. What's your pain level on a scale of 1 to 10? That scale of 1 to 10, those are just numbers that represent categories. We can create a number line that represents those different categories. In this case, we won't need that. Okay, bit of a side note there. I'm sorry about that, but I want you to know that we could create a numerical scale for different categories. In this case, we won't have to do that because whether he lives or he dies, there is a value that's attached to each. For example, if he lives, what does he get from life insurance? He doesn't get anything, but instead he loses $250 through that year. That's the premium he had to pay for his insurance policy. But if he dies, what does his family get? His family gets $150,000, right? Well, almost. They get $150,000, but they lost the $250 they had to pay in premiums. So that means that on the whole, their family gets $149,750. There we go. Those are values that are attached to each different category. All right, let's look at the probabilities. What's the probability that he lives? 99.8%. What's the probability that he dies? It's the complement, 1 minus 99.8%, which means 0.2%, 0.002 as a decimal. Okay, now we can take these values and their probabilities and calculate an expected value. So a value of negative 250 has a probability of 0.998, and the value of 149,750 has a probability of 0.002. If we multiply those out, we get those two values, add them together, the expected value is $50. Okay, so what does this $50 mean? This $50 means that on average, a 30-year-old man will gain $50 a year. If you take 1,000, 10,000, 100,000 30-year-old men with the same condition of $250 premium, 99.8% chance of living through the year on a $150,000 policy, if you get 10,000 men, 30-year-old men in the same scenario, then go through them. Most of them will be paying $250, but every once in a while there will be one who does pass away, and so his family is benefited by the insurance company. If you take all those premiums and payouts, on average, the insurance company would be giving $50 a year to each of these men. Okay? This is good news for us. If we had an expected value of negative, that means that more often than not, people would be giving money to the insurance company, and that would benefit them, but we would lose the money. It's called gambling, okay? And that's going to be our third example, is actual gambling. In the case of life insurance, this is actually good for us. So, and sorry, I'd love to talk some more about this. If you have questions, feel free to ask. But let me just make this one point here. Always, whenever I bring this up, I always get the question, well, if on average the insurance company is handing out more money than what they're pulling in, how do they make money? Well, remember that the premium depends on the probability of living. So if the probability of living drops, the premium increases, which means that as someone's health starts to fail, as someone gets older, the probability of living through the year drops, their premiums shoot through the roof. At this point, now the insurance company will be getting more money than what they pay out. So in this particular case of a 30-year-old man, prime of his life, healthy, he's not likely to pass away, very unlikely to pass away. So it's unlikely that the insurance company will have to pay out. They're losing a minimal amount of money on him. But as he gets older and older and older, his premium increases. Pretty soon, the insurance company will benefit from that more than they'd have to pay out. Point of this exercise is, how do we calculate expected value and how do we interpret it? And that's this example with life insurance. In the next example, we're going to talk about a more negative expected value, and that is in a gaming or gambling scenario.